In this video, we'll be talking about the very basics of the independent t-test, including when we use the independent t-test. We're talking about independent means, and so this is a different test than the dependent means t-test, even though they share that name in common of being t-tests and having, so we'll see that with the t-tests, we have two scores actually in both situations, but where these scores come from is actually going to be a little bit different. And so compared to the dependent means t-test, moving into now the independent means t-test, we actually are going to have only two steps changing. So steps 2 and steps 4. Step 3 will stay the same. We'll still be getting our cutoff scores on the t-table, just like we already looked at and practiced. So again, first thing that we always think when we have a new test is, when do I use it? What situation does this test apply to? And because it's a t-test, we're going to use our independent means t-test when the population variance and population mean is unknown. And so that's what these t-tests have in common. The difference now is that our t-test for independent means, when we talk about them being independent, this means that we have two sets of scores, but each set of score is from a different group of people. And so that's the independent part. When we talked about the dependent means t-test, we said that these scores are linked. They're dependent to some degree on one another because these are from the same people, two scores each from every participant in our study. Now we actually have two groups of people and we're getting one score from each person. So we still have two sets, but these are from different individuals. And so what does this do? So essentially what we're going to be doing is comparing the means of our two groups. And so this is a really, really common kind of study, common study design, common test that we'll be running. And actually this test and the test that we'll do after this, that will start in just a couple of sessions, we'll be using these kinds of tests quite often in the real world. And so this is something that particularly if you're in behavioral sciences or health sciences, nursing, any of these kinds of areas, which I think most of you guys are, these are going to be really relevant, both as you might be running studies and as you're going to be reading other research and in your fields. And so for instance, when we're looking at two means of two different groups, we can think of that like a control group and an experimental group. One group gets maybe just some kind of activity that should be neutral. One group gets the therapy. One group gets a placebo. One group gets a medication. And that's exactly what this kind of test is designed to work with. So what's our comparison distribution here? We know that our comparison distribution always looks like our sample. And what our sample is going to give us is it's going to give us the difference between two means, between the means of each of our groups. And so our comparison distribution is going to be a distribution of differences between means. And that's what we'll be looking at. And so in theory, the idea here is that we have randomly selected one mean from the distribution of means of each of our two populations, one for each of our groups. And then we subtract the mean of the second distribution, the random mean that we picked from that second distribution, from the mean, that random mean we picked from the first distribution. And that's that subtraction, that difference is what then we're going to start building our histogram with. And we're going to keep doing that. I'm going to grab a mean from my second distribution, grab a mean from my first distribution, do that subtraction, and start and build that histogram, add that into my distribution of means. And so I'm going to keep doing this. And again, this is how we build our distribution of differences between means. Of course, just like with our other distributions of means, we don't actually have to go through this whole process. There are going to be some mathematical ways that we can get this information based on our population, our assumed population mean, and our estimated population variance or standard deviation. And the idea here is that we're going to base the variance of our comparison distribution on the estimated population variance, actually of both populations. And so this is going to move kind of a step forward where we saw in the last t-test, in our dependent means t-test, We were going to get the estimated population variance based on our different scores, based on one set of scores essentially that we used those raw scores to get. Now we're going to actually need to get the estimated population variance for both of our populations using both of our samples. And then we're actually going to kind of combine those.